Hey everybody! Today we're going to learn about density. We'll explore water density, like in lakes and oceans, and we'll talk about the effect that salt has on buoyancy, like making things float. And then we're going to do an activity where we can see density working in action. So let's begin. Before you learn about density, you need to know what mass and volume are. Those are two units of measurement, so let's explore those. Mass is the amount of matter an object contains. And volume, well, that's how much space it takes up. For example, a bowling ball and a basketball, they're about the same volume as each other, but the bowling ball has much more mass. Now put them together to get density. Density is a word that we use to describe how much space something takes up, that's its volume, in relation to the amount of matter in that object or substance, its mass. Another way to put that is that density is the amount of mass per unit of volume. If an object is heavy and compact, it has a high density. If an object is light and takes up a lot of space, it has a low density. An object's density, mass, and volume are all related to one another. Specifically, the density of an object is equal to its mass divided by its volume. If you've ever floated in the ocean, you might have noticed that it's easier to float in the ocean than it is to float in a swimming pool. If you had to guess, why would you say that is? Well, it's just one word: salt. When salt is dissolved in water, as it is in ocean water, that dissolved salt adds to the mass of the water and makes the water denser than it would be without the salt. If you had a choice of drinking water from your sink versus from the ocean, you'd probably pick the tap water. Why? Because ocean water is so salty, of course. We refer to the dissolved salt content or the saltiness of a body of water by calling that its salinity. Because objects float better on a dense surface, they float better on salt water than fresh water. Salt water has more density, and that's why you can float better in the ocean than on a lake. You can make salt water at home by creating a solution, and a solution is just a mix of salt and water. Let's try it real quick. This isn't our main activity, this is just a little teaser. If you have a couple of peanuts and some salt at home, you can try it out for yourself, and you can make a saltwater solution and measure the density of that with a peanut. So if you want to do it with me, you can, or you can just watch. I'm going to fill 2 cups with water. This is just fresh water from the tap. And then I'm going to leave 1 cup as fresh water, and the other one I'm going to put a bunch of salt in to make a solution. Now I'm just going to take 2 ordinary peanuts and I'm going to drop 1 in each cup. Which one do you think will float better? Can you see that? This peanut is floating around in the salt water. And this one, it's sunk all the way to the bottom. This is the fresh water. Salt water. The last word that I want you to remember is buoyancy. Buoyancy means the tendency of an object to float or rise when it's in a fluid, like water. So this peanut is demonstrating buoyancy. This is called a Cartesian diver, and Cartesian divers seem to bob up and down for no particular reason. Some people that think that you can use them for magic reasons, almost like a magic 8-ball, where you ask it a question, and if it bobs up and down, the answer is yes. Hey Cartesian diver, am I incredibly handsome? A little bob. I guess I'm just a little handsome. But there's no evidence that Cartesian divers are magic. It's just something that's fun to think about and not scientifically true. But what is scientifically true is that they can help you understand buoyancy. So we're going to make one of these today, and then you'll get to play with it. For this activity, you need a few things. You need some paper clips, tape. You need a straw. This is a straight straw. If you have a flexible straw, one of those bendy straws, that would be even better. But we can make it work with whatever kind of straw you have. You also need some rubber bands. You need a 2-liter bottle with the cap. And then you need just a jar of water to test out your thing in. you want to start with your straw. Now, if you have a flexible straw, you just go ahead and bend it and you'll be done. But if you don't have a flexible straw, you have to use a straight one like this. And the way that you can bend this one is that you actually pinch it in the middle and then bend it over like that. Okay, so it should look a bit like this. And what you don't want to do is have any kinks in it. You just want kind of a straight line like that. All right, so it should look like this. If you've done it with your flexible straw and you have extra straw hanging off, you can just cut off the extra part so that the two ends meet almost at the same place. Now take a piece of tape and just tape the two ends together so that they don't move around. But make sure that you do not tape over the holes there. You need those holes so the air and the water can get in. Okay, now the idea is that this is your diver, but he needs some weight, or she, whatever it is to you. Your diver needs some weight to be able to bob up and down, because if it doesn't have any weight on it, it's just going to shoot to the top and stay up there. But we want it to go up and down. So to add some weight, we're going to put paper clips on. But we need something to hook the paper clips onto. So we're going to tie a rubber band around the bottom. And be careful with your rubber band, because what you want is that it's tight enough so the paper clips can stay on, but not so tight that it squeezes these shut. All right, do you see how mine are nice and open? Again, that's what you want. Now you're going to add some weight to it. And that's your paper clips. I think you should start with maybe 3 or 4 paper clips, and then we'll test it out. And this is what our jar of water is for, so we can test it out before we put it in the 2-liter. So go ahead and hang your paper clips on your rubber band. So just stretch out this side a little bit and then feed it through the rubber band so it hangs off. I'm just going to put 3 on here and see how that does. Okay, so I'm ready for my first test. And this is here. When I put it in here, I want to see what happens. Does it sink or does it float? So if it sinks all the way to the bottom and stays down there, it's too heavy. And if it floats way up at the top like this, it's too light. We want it to be sort of in the middle and just staying there without our help. So if it's like this, add more weight. I'm going to add a couple more paper clips. Still needs more weight. Okay, that's pretty good. Look at that. It doesn't touch the bottom and it's just sort of peeking out the top. I actually might even add just one more paper clip. There it is with one more paper clip. Perfecto. Very good. If yours is not floating at this point in your test jar, check your straw. Because if you get a tear or a rip in your straw, it's not going to work. You'll have to replace it. So you want to make sure your straw has integrity. Now take your 2-liter bottle, and if you haven't already, fill it most of the way with water. And make sure you have your cap, because when the cap goes on, that adds the pressure that you need. Take your Cartesian diver and just squeeze it a little bit without breaking it, and try to fit all the paper clips through the top, and then push it down so it goes in. All right, he's in there, or she, whatever it is to you. Put the cap back on, and put the cap on tight. If you don't put it back on tight, you're going to regret it, because you're going to squeeze the bottle and it's going to shoot you right in the face. You're going to get all covered in water. Now squeeze your water bottle to make it go up and down. And you can play with this all day. You can do all sorts of games to see, can you make it stay in the middle without going all the way down? Can you keep it at the bottom? Can you shoot it to the top? How quickly can you shoot it to the top? So this is your Cartesian diver, and the straw is buoyant in the water, but it's the weight of the paper clips that make it want to go down. So it's the contrast of the buoyancy and the weight that make it fun to play with. If you find that it's too hard for you to squeeze the bottle, that you squeeze it and nothing happens, you can just pour a little bit of water out, and that'll release some of the pressure, and then it should be a little easier to squeeze after that. If you ever come to the point where you want to rescue your diver, you can make your own fishing pole with a straw and some string, and then a paper clip that's been bent to look like a hook. And then have fun, go to town, see if you can perform a rescue mission for your Cartesian diver. That's it for today. Keep exploring buoyancy and enjoy your Cartesian diver.